In this video, I'm going to solve an exact equation. So solve 2x y cubed minus 6x squared y squared dx plus 3x squared y squared minus 4x cubed y dy equals 0. So the shape, it is as an exact equation, but I cannot conclude that until I take the test. So I'm going to color code them. This would be, the yellow one would be my function m of x and y. Just the yellow part, no dx, and the blue one will be the function n. The condition of exactness is the derivative of m with respect to y must equal the derivative of n with respect to x. So let's do that. So the partial derivative of m with respect to y is, well, 2xy cubed minus 6x squared y squared differentiate with respect to y. What does that mean? It means everything that contains x, it's a constant. It's considered as a constant. So 2x times y to the third prime is 3y to the second minus 6x squared is the constant, and y squared differential with respect to y is 2y. So we get 6xy squared minus 12x squared y. This is the derivative of m with respect to y. And the derivative of n with respect to x, 3x squared y squared minus 4x cubed y. Again, this time we consider x as the variable and y as the constant. So it's 3y squared times x squared prime is 2x minus 12x squared y. So 6y squared x minus 12x squared y. If we compare these two, we got the same thing, and that means the equation is exact. So it means equation, let's call it star, is exact. So let's start solving it. So we know that the dx equals m. That's how we started. We defined m. So then the function f of xy is going to be integral of m dx. But m was 2xy cubed minus 6x squared y squared dx. So when we calculate that, again we consider y the constant, and now integral of x is x squared over 2 minus 6 y squared, and integral of x squared is x cubed over 3. So x squared y cubed minus 2x cubed y squared plus some constant. But since we are differentiating with respect to integrating with respect to x, we'll consider our constant as a function of y, and this is a good result to keep in mind. And let's do the same thing for the definition of n was the derivative of f with respect to y. So f of xy is going to be integral of n dy. N was given to be, let me make it smaller, 3x squared y squared minus 4x cubed y dy. And let's solve it. So it's 3x squared y cubed over 3 minus 4x squared y squared over 2 plus a function of x, let's call it g of x. So x squared y cubed minus 2x squared y squared plus g of x. Here I just made an error. When we integrated this, it was 4x cubed. So 4x cubed, I just copied wrong. So now when let's label this one, let's color it. Now they are both the same function, right? So they must be equal to each other. So let's compare them. X squared y cubed, x squared y cubed, they're the same, that's perfect. Minus 2x cubed y squared minus 2x cubed y squared. Then there is a function of y, which there is no function of y on this side, so it must be 0, right? So by comparing them, f of y must be 0. There is no function of x only, so that must be 0. So then this equals c. This is the solution of the exact equation.